Hello, welcome back to the channel. So let's continue our previous video and do this question, which is based on solving improper integrals which have unbounded integrand. So by unbounded integrand, again, what we mean by unbounded integrand is that whenever you are solving a definite integral for which your function has a discontinuity which lies in between the interval specified for your definite integral. So if that's the case, you call your definite integral as an improper integral with unbounded integrand. So we already covered the concepts which you require in order to solve these type of questions in the previous video. So I'll highly suggest you to first watch my previous video in order to get the full context of this video over here. So as you can clearly see in this integral over here as well, for your function, you can clearly see that your function is not defined at x equals 1, right? Because at x equals 1, your denominator is 0, which clearly indicates that this function is not defined at x equals 1, right? But for the definite integral interval that you are calculating the area under the curve for, you have x equals 1 point over here, right? So that is why this is an improper integral with unbounded integrand, and it also obeys this case over here, right? This is what we know from the previous videos. So we know that the integral over here obeys the second case. So in order to solve this integral over here, we'll have to first introduce a new variable capital T and solve this definite integral over here such that the capital T lies between a and b. And once we solve this definite integral over here, we'll have to take the limit of capital T approaches b minus in this case, right? So let's use all the concepts that we learned in the previous video in order to solve this integral over here. So now we know that we have to solve this definite integral, which is from 0 to 1 x to the power 4 x to the power 5 minus 1 dx, and we know that we'll have to introduce a new variable t such that t lies in between a and b, which means t lies between 1 and 0. So our new variable t lies between 1 and 0, and for calculating this, we'll have to calculate the limit capital T approaches b minus, so b is 1. So capital T approaches 1 minus is basically the left hand neighbor of 1, which means you are basically approaching 1 from the left hand side, and 1 minus is very close to 1. So you are solving limit T approaches to capital T approaches to 1 minus for the integral 0 to capital T x to the power 4 upon x to the power 5 minus 1 dx over here. And in this question, in addition to evaluating this integral, we also have to state whether it diverges or converges. So divergence and convergence are very important concepts in improper integrals that we'll cover in the next videos. But what they basically mean is, if you're saying that your definite integral converges, that basically means you have a solution, you have a real solution to your definite integral. But if you're saying that your definite integral diverges, you don't have a real solution to your definite integral at the last. Don't worry, we'll cover the concepts in detail when we'll solve this definite integral over here, and we'll see whether our definite integral converges or diverges. And we'll also cover these concepts of convergence and divergence in the next videos as well in detail. So now we have to evaluate this integral over here. We know that we can clearly evaluate this definite integral by using substitution, because if I substitute x to the power 5 minus 1, I can clearly see the derivative of x to the power 5 in the numerator. I can do some manipulations with the constants, but I see x to the power 4 over here, right? Which gives me an idea that this integral can be easily solved using substitution. So let's solve this definite integral using substitution. So if we assume our u function to be x to the power 5 minus 1, we know that our du would be 5x to the power 4 dx, right? And now we know that since this is a definite integral, we'll have to change the endpoints as well accordingly. So when our x is equal to 0, which is our lower endpoint, our u is equal to minus 1, right? And when our x is equal to capital T, which is our upper endpoint over here, our u is equal to capital T to the power 5 minus 1, right? So now after doing all these conversions, we can change this definite integral into a simpler form using substitution, right? So if we change this definite integral over here in a simpler form using substitution, it will simply become limit capital T approaches to 1 minus, this will be changed to minus 1 to t to the power 5 minus 1 So capital T to the power 5 minus 1, and the inner integral will basically be changed to, so we know that x to the power 4 dx, which is in the numerator, is basically du upon 5. So this is du upon 5, and then your denominator is x to the power 5 minus 1, which is u. So this would be 1 by u over here, right? And now we can simplify this one. We can take the constant out. So 1 by 5, then limit t approaches to 1 minus. You know that you can take the constant out of the limit as well, right? The answer won't change. You can keep the constant over here as well. But in order to simplify our expression, let's take the constant out of the limit as well. And this would become limit t approaches to 1 minus integral of basically 1 by u du with the endpoints minus 1 and t to the power 5 minus 1, right? And we know that the integral of 1 by u is log u. So this would be simply 1 by 5 times limit capital T approaches 1 minus, this is natural log of u, natural log of the absolute value of u with the endpoints minus 1 and capital T to the power 5 minus 1 over here, right? So now in order to solve this definite integral, we can plug in the endpoints over here. You know that if you'll plug in the lower endpoint into the definite integral, it will be basically natural log of the absolute value of minus 1. So it will become ln1, ln1 is 0. So you won't have a second expression in this definite integral, right? So your solution to this definite integral will basically be 1 by 5 limit capital T approaches 1 minus natural log of the absolute value of capital T to the power 5 minus 1, and that's it, right? Because you won't have a second expression over here because ln1 is 0. So now if you take the limit of capital T approaches 1 minus for this natural log expression, you know that if your capital T approaches 1 minus, this expression will basically approach the natural log of 0, which is minus infinity. So we know that this limit does not exist. This limit will be basically minus infinity because we know that this limit does not exist. And since we don't have a real solution to our improper integral over here, we can clearly say that our definite integral in this case diverges because we don't have a real solution to our improper integral over here. If there was a real solution to this definite integral, you would have mentioned it as a convergent integral. But since in this case, we know that after solving this improper definite integral, our answer is not a real number. It basically means that our improper integral diverges. So that's it for this video. I hope that makes sense. Feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.